Welcome to this explainer. Let's just jump straight into it today because we're looking at something genuinely fascinating, the power of neutralization. We're going to explore a chemical process that is so fundamental it literally operates everywhere, from the tiniest test tubes in a science lab right up to massive planetary ecosystems. It's this incredible chemical balancing act that's happening inside your own body right now and out in the wider world. So let's get started and see how this invisible chemistry shapes everything around us.
So think about this for a second. What do indigestion, acid rain, and brushing your teeth actually have in common? Sounds kind of like the setup to a weird joke, right? But the answer definitely isn't a punchline. It's a single, incredibly powerful chemical reaction. We experience these things completely differently. One is a painful stomach ache, another is a huge environmental hazard, and the last one is just your daily morning routine. Yet, believe it or not, they are all solved by the exact same scientific principle. Here's a quick roadmap of what we're unpacking today. First, the balancing act. Then, what neutralization actually is. We'll look at lab precision and burettes, check out a really cool rainbow experiment, dive into everyday life applications, and finally, look at healing the environment. All right, part one, the balancing act between acids and alkalis. To really wrap our heads around neutralization, we have to understand the core conflict here. Acids and alkalis are basically two opposing forces. They sit on completely opposite ends of the chemical spectrum. When you mix them together, they react. If you have an alkaline liquid and you slowly add acid to it, it becomes less alkaline. The pH balance actually begins to shift. But, it's a very delicate operation. If you add too much acid, the mixture overshoots and becomes acidic. Add too little, it stays alkaline. The goal is to find that perfect, safe middle ground where the two completely cancel each other out, giving you a perfectly neutral solution. Moving right along to part two, what exactly is neutralization? Let's nail down the chemical definition. We've talked about the balancing act, but what is strictly happening chemically when these liquids mix? Well, neutralization is a chemical change where an acid and an alkali react and cancel each other out to form a neutral solution. The absolute crucial point here is that this isn't simply a physical mixing process. It's not like stirring red and yellow paint to get orange. No, this is a real chemical reaction. When the acid and the alkali meet, they break apart and recombine. Entirely new, neutral substances are formed out of this clash. The original acid and the original alkali are just gone, completely replaced by something new. Take a look at this word equation. Think of it like a recipe for a specific neutralization reaction. We start with hydrochloric acid, which, by the way, is a very strong corrosive acid. To that, we add sodium hydroxide, a strong and highly reactive alkali. But look at what happens when they react. They produce sodium chloride and water. And sodium chloride, that is literally just your standard everyday table salt. So you take two very intense hazardous chemicals, and through the sheer power of neutralization, they transform into ordinary, totally safe salt water. It's absolutely incredible how chemistry works to turn danger into safety. Up next, part three, lab precision and burettes, and how we actually measure this change. Because this chemical change is entirely invisible to the naked eye, scientists need specialized ways to control and observe it. Enter the burette. It's a tall, thin glass tube, and when you're making a neutral solution in the lab, precision is absolutely everything. You can't just dump a bucket of acid into a bucket of alkali and hope for the best, right? You use a burette because it lets you add the acid to the flask incredibly slowly. We're talking literally just a few drops at a time. It has this tiny tap at the bottom that gives you absolute control, making it so much easier to catch the exact split second that solution hits perfect neutrality. Let's walk through exactly what happens in that flask. Step one, the flask starts full of an alkali, like sodium hydroxide. Let's say it has a pH of 13, strongly alkaline. As the acid drops in from the burette, the pH slowly drops. Step two, after exactly the right amount of acid is added, say 25 cubic centimeters, the acid has completely reacted with the alkali. The liquid is now neutral, hitting a perfect pH of 7. But, as step 3 shows, if you get a little sloppy and just a tiny bit more acid drips in, the pH drops to 6. It's no longer neutral, it's weakly acidic. And that is exactly why that burette's precision is so vital. Which brings us to part 4, the rainbow experiment, visualizing neutrality. Now, you might be wondering, is there a way to actually see this reaction taking place? Yeah, there absolutely is. This is a beautiful little activity to visualize different pH levels. First, you drop a crystal of washing soda, which is a strong alkali, into the bottom of a test tube. Second, you carefully add water and a few drops of universal indicator. That indicator acts kind of like a chemical mood ring. It changes color based on the pH. Third, you carefully pour some hydrochloric acid right on top. The number 1 rule here, do not shake the tube. Finally, you just leave it to stand completely undisturbed for a few days. And because you didn't shake it, the chemicals only mixed very, very slowly through diffusion. Just look at the incredible gradient it makes. At the top, the indicator is red, showing it's strongly acidic right where the pure acid sits. In the middle, where the acid and the alkaline washing soda have met and neutralized each other, it turns a bright yellow, showing it's more weakly acidic to neutral. And way down at the bottom, where the crystal is dissolving, it's a deep purple or dark blue, meaning it's still a strong alkali. You can literally see this chemical war mapped out in living color. All right, part 5, everyday life applications, taking this from beakers to bodies. We've seen the perfect laboratory setups and those beautiful gradients in a test tube. But how does this exact same chemistry play out in our daily lives? Well, it turns out you're running neutralization experiments on yourself almost every single day. Take indigestion. Your stomach naturally produces hydrochloric acid, the exact same strong acid we were just using in the lab. It's there to digest your food, but too much of it causes painful indigestion. Those antacids you buy at the pharmacy, they're just alkalis. You swallow them to neutralize the acid. Or think about brushing your teeth. Bacteria in your mouth produce acid that causes tooth decay. Toothpaste purposely contains an alkali to neutralize that acid and protect your enamel. Basically, your bathroom cabinet is a fully stocked chemistry set. Finally, part 6, healing the environment through macroneutralization. We can go even bigger than the human body, though. The principles we saw in that tiny glass burette are scaled way up to save entire ecosystems. For instance, in some places, the soil is naturally super acidic, meaning crops just won't grow. To fix it, farmers load up tractors and spread lime, which is a powdered alkali, across massive fields to neutralize the soil. And it gets even crazier. In some parts of the world, acid rain drops the pH of entire lakes, killing off the plants and fish. To combat this, countries will literally drop massive quantities of alkalis directly into the lakes from the sky to neutralize the acid and save the wildlife. The contrast in scale here is just staggering. On one hand, you have a little bottle of antacids sitting quietly on a shelf to fix an upset tummy. And at the exact same time, you've got a helicopter soaring over a forest, dropping a massive plume of alkaline powder into a dying lake. It seriously looks like an action movie scene. But the chemical rule running both of these situations is exactly the same. An alkali is being introduced to cancel out an acid. Whether it's a few milligrams in your stomach or literally tons of powder falling from an aircraft, neutralization works the exact same way. So that leaves us with this final thought. We've seen how acids and alkalis are locked in this constant push and pull, a chemical tug-of-war that dictates the health of our bodies, our soil, and our oceans. You've seen the absolute precision it takes in the lab and how huge it gets out in the wild. So I want to leave you with this. If acids and alkalis are constantly at war, how are you using neutralization to keep your own world in balance? Next time you brush your teeth or grab an antacid, just remember the incredible, invisible chemistry you are putting to work. Thank you so much for joining me for this explainer. I hope you found it as mind-blowing as I do.